welcome. Welcome to another episode. And today we have a guest, and unlike we usually do, we first ask if there are any questions. Since our guest time is valuable, let's postpone any questions to the end, or if you have something specific that you want to ask Stephen as he maybe shows or elaborates on things, feel free to interrupt him and ask questions. But if you have general HDF5 questions, please keep them to the end, and then I'm happy to answer them if I can. Okay, so today's topic takes us into the fascinating world of financial market data, specifically tick data. And if you are unfamiliar with tick data, pretty much any change that occurs in the life, so to speak, of a financial instrument is represented by tick data somehow. And whether it's a price or a quote on an exchange, and it's if you wish, the most granular level of any kind of market activity, market meaning financial market. And of course, this level of detail is absolutely critical for financial analytics and enables sort of deep insights for backtesting frameworks, algorithmic trading systems, but also sort of scientific and financial time series analytics. And collecting, since we are here about data management and storing and collecting data, this is a significant challenge just due to the sheer volume of this tick data. And one standard format to acquire this tick data is to capture sort of the raw network traffic from these exchanges where these instruments are traded, and including sort of market data streams. And there is a standard, or there are a few standards, but one of the best established standards is the so-called PCAP, or package capture file format. And this is excellent for sort of the raw capture. However, if you want to do then sort of the back testing, the analytics and all these things, it's not really optimized for that type of access. And that's where today's guest and his latest sort of project comes in. And Stephen just released a new tool that's called IEX2H5, and he'll explain it. And yes, first of all, Stephen, thank you for joining us. And many of you might know Stephen. He's a longtime contributor and supporter of the HDF5 ecosystem. Remember, for example, H5CPP and projects like that. So it's I'm absolutely delighted to have Stephen back here today. And yeah, I prepared a few questions, but maybe, Stephen, do you want to say something before we get going here?
First of all, thank you very much for being here, and hello to everyone who I have met before, and to the ones that I have not yet. This discussion will be about tick data, market data, and this Lily utility that ventures into performance and performance measurements when it comes to stock market events recorded on in some specific format, packet capture format, which is a raw representation of Ethernet frames. And the idea here is to somehow make this information available to others in a format that is accessible from various platforms, and it has good performance characteristics. Not only that, but its structure allows you to interpret the data in an easy and accessible way.
Mm-hmm. Okay, so thank you for that. And maybe let's start. Maybe can you tell us something in general about, okay, I use this acronym IEX as if everybody knows or should know what IEX stands for. So, and I forgot to mention, when I said that Stephen just released this project, this software. It's actually available on GitHub, and we will see the address later, how you can get a hold of it. But yeah, so would you mind telling us something about what is this IEX thing, and the tool that you developed, what is its primary function, and what problem was it designed to solve for those working with IEX market data?
IEX is one of the US exchanges. And what's unique about this exchange is it makes its data stream available for free of charge under certain conditions. I'll get back to these conditions, as one of the conditions is the attribution, which is required whenever that data is being used. And this utility's primary purpose is to allow you to either have access to high quality market data or study high quality market data's properties. That's in a nutshell.
Mm-hmm, mm-hmm. And we also have emphasized sort of the high performance nature. We talked about this tremendous volume of that data, and we'll see a little bit of that later. Could you elaborate on how you achieve this high throughput sort of processing these large volumes of data, and maybe sort of what specific design choices or technical implementation sort of contribute to the speed and efficiency in the processing that IEX2H5 is doing?
Well, at this point, I only can provide some sort of a ballpark or a feel what we're speaking about. The data set is around 8 terabytes in a compressed packet captured format. When we're speaking of level 1 data, which is just a reflection of what happened on the market in a best case minimal scenario. Another way to put, that's the top of the books. Another data set is also available where you get the full stream of the details or the statistical distributions of the prices, which is called the entire book. This information is in compressed format, about 3:4 ratio, and contains additional sideband information related to Ethernet frames or the actual UDP protocol. And top of that layer, the IEX protocol, which in most cases not useful or not that useful for examining what happened on an exchange. And the useful information is the actual orders or the price or the actual trades.
Mm-hmm. Mm-hmm. And of course, I think our listeners will not be surprised to hear that this is all implemented in C++, and of course uses the HDF5 library in some form. You mentioned compression already. I believe in this case you just use Gzip compression at this point. Of course, there might be better compression algorithms available for this type of data. And I also know, I think you're using I believe it's called libzng, sort of the new implementation of Gzip to get better compression performance. But then, of course, yeah, I think you spend a lot of time optimizing the throughput by carefully scheduling. I think, do you use any kind of multi-threading in your implementation?
So first of all, thank you very much for the question. Now we are venturing into an interesting zone, and one of them is the size of the data. The other factor than the size, what's important is like how fast you can process the data, which is for some reasons there is some relationship between the two. But just going back to the size, one way of making something smaller is enriching the information that it has. In another way to say, relation to the space it takes up. That's probably the best way to put it. And this is what compression does. The compression method is used for the original data set is Gzip and is recorded in a stream, which is different from how some other compressors approach the entire problem. And this includes the HDF5 system, which allows us to compress something in quantums, in packets. So going back to the stream approach, that means that we have to continuously pump information into a pipe, and then we somehow, by some magics or some mathematics, we expand that information and we get back the original.
Mm-hmm.
This mechanism, originally in the original design, when I started doing this one somewhere in early 2017 or end of 2016, was using the Gzip compressor and then pushing into a Unix pipe. This current package that I made available for everyone contains the entire pipeline, and indeed using the new generation Gzip compressor library. But this is how far one can improve on the intake. Now, taking the argument onto a different ground, one can make significant differences. And in two aspects, one of them is the computational speed, or how long it takes something to actually compute. That includes the internal overhead of tossing information here and there. And the other part is the actual output size, how much it can be compressed. And when we're speaking of these, then mathematics comes in, and when mathematics comes in, things go all over the place. But when the current standing is, when it comes to information compressing, is that how much we know about the information, whether we can exploit structure. Indeed, is the case. When you spend professionally so much time with information that you find on exchanges, then you know how information, or what sort of information is important, what sort of information is not so much. This is just the idea how what already has been done with image compressors like JPEG and many others. From a mathematical point, you pull a decision line or a boundary of what's the information that really matters for you and what doesn't, and you just cut the rest of it. Mm-hmm. This is happening in JPEG-related compressors. So the question is, if we move into this territory, can it be done with the information? And if it is done, what are the impacts? Mm-hmm. So these ones are the areas that this utility allows you to explore by providing you access to the original data stream. And indeed, I spent some time recently on exploring the possibilities of how much compression can be done. And it could range to between 50 to possibly even 150 to 200 times of a compression, which is a significant space gain when you consider most of the US markets involved and the record information. Like single market could range around 10 gigabytes per day. Like this is a small market, but larger markets can have around 50 to 80 gigabytes per day. And we're just only speaking of partial information. Mm-hmm. And there are plenty of markets in the US and all over the world. Mm-hmm. So on a daily, like by days, like we're speaking of information that there is a significant cost to actually store. So if we can reduce the cost, then it totally makes sense why someone would go into this direction. Mm-hmm.
Okay. Now, of course, let's get to the core of why this is so compelling to listeners to this clinic. It's the use of HDF5, and maybe you can elaborate a little bit on why did you choose HDF5 as the target format for this financial data? And what were sort of key design decisions that you made when you laid out the data? Because you could think, well, yeah, are there more sort of custom tools like time series databases available and so forth that you can pay a lot of money for? So what were sort of the design decisions, and yeah, why did you chose HDF5 to begin with? And yeah, how happy are you with that compromise that you have found here? Mm-hmm.
I think the straightforward answer would be the technical properties of HDF5, but reality is different. Interestingly, the data storage or storing tick data from custom proprietary applications somewhere in the early 2010s motivated me to develop the core idea of H5 CPP, where I encountered of data storage in a custom format, and then you have to, which led to various problems. And during that research, I examined various public formats and came across HDF5, which had all the good properties that I needed. The ability of loading the data into various systems, and that time was not entirely clear to me what it would be. Python was not the most popular language for data processing in the early 2010s, the way I looked at it, at least from my perspective. But I did consider these aspects of it. And then I developed the basic idea of H5 CPP, and then with you, Gerd, later on, we homed it, and one of the aspects or one of the properties of H5 CPP processing line is an internal mechanism that allows recording of tick streams with directly into the HDF5 internals, also called chunks. And on it, one can design custom pipelines, similarly what comes with the HDF5, but now having direct control over that area of the code base without touching the HDF5 line. And because of all these technical and historical factors, the only choice to go forward is using HDF5. But there were other motivating factors. Converting a data set for others and should be in a way that actually they can load it into their own system. Mm-hmm. And that's not well defined. It indeed could be Python, which is nowadays probably gained so much popularity that probably one of the most popular data processing language, though I could be called on that one. And I'm not authoritative to say that. But my favorite is Julia, which is directly HDF5 based, and previous favorite was R, which led me to HDF5 with RCPP and many other projects that actually originated from Chicago. MATLAB, who is in the science world, MATLAB is a de facto tool that you come across during your curriculum. But HDF5 is not limited to these languages. It's ubiquitous. It's everywhere.
Mm-hmm. Great. Now, for all those for whom this was maybe a little too abstract, would you mind sort of giving us maybe a little demo of the tool? I mean, maybe show the GitHub repo, but then also, yeah, you mentioned Julia, show it in action, what you can do with it, if you don't mind.
Oh, absolutely. Let's have a quick road trip, so to speak. Given that I find again the option of how to share the screen, which
Yeah,
is a
at
green
bottom
button
there
here,
should be a
right?
green button, share, and then
Excellent. And now I have so many screens to share. I have to pick the right one, and I hope I did. And
yes,
if
we
I
see
did,
the
then what you
IEX.
should be seeing is IEX exchange and the data set, correct?
Yes.
Oh, excellent. So we are on the right side. But before actually dive into that, there is a quick thanks to IEX for sharing the data, which is not only a nice gesture from them, but is very useful for researchers when it comes to TIC data. And in 10 points, they summarize the requirements from the licensing point of view, but just to cut in short, one of the requirements is to attribute them and thank for these data sets. There are links to this one according to the legal requirements. You can find it on the projects, but other than that, what you can see is the listed data sets here, usually updated a day after the event. So that means that we have the available data for yesterday, and we're going to explore these ones just for the fun of it. Other than that, the data set goes pretty much back to years, which is quite useful if you're exploring space, something called backtesting, or you're building these frameworks. That's basically the idea, is that the underlying idea behind backtesting is that some way the past or the events of what happened in the past influence what is yet to come with some certainty. And that's the whole entire field dedicated to that, like how much this can go and how much can be right or wrong. But that's not the point of this discussion here. So you can just click on the data set, whichever you wish. And what we are exploring here is the TOPS data set, or top of the books. The deeps is the layer level 2 crypto world. I spent too much time recently in the crypto world. So it's not layer 2, level 2 data set, which is the entire older books. And this is a new data set. I'm not so familiar with that one. But by clicking them on the links necessary, you can just download them. So what I have here on this newly created GitHub repository is the project itself. It has some interesting properties that recently I picked up from the last place that I spent a few years developing trading systems. That how the entire project is set up. But what's in short here is testing against various compilers that can be done on GitHub for free, which can be important for projects like this, and some of the performance metrics. Here, these ones are quick and dirty performance metrics. Actually, I'm planning to get a little bit into it at some point, and how to use the project and, of course, the thanking part. Now, let's move on to something more interesting. There are various programming languages that the information can be consumed or processed. Eventually, with time, I'm going to add examples to the projects. Currently, what I could prepare in the past few days or yesterday is a quick overview in Julia. And what we're going to see, or actually what we can do here is just to show like how to invoke this utility here by converting some information that I already stored in HDF5 format into HDF5 format, which sort of begs the question, what's the whole point? So I think the better way to explain what's happening is just going through the actual examples, and then somehow it becomes more, how to say, or less opaque. So the information what we have in here, and let's just put aside some details like package management in Julia language. One of the how to say, like one of the first thing that we should do is some way load the information into Julia. And what we're going to do is swap these windows. Instead of the RTS, we're going to go with a different file format. And we're going to go that line by line. So if we load some HDF5 container, and the first thing that we notice, there is some information in it. And some of these informations are indices, which just tell us how we refer, or in what way we refer to some other information somewhere else. So you could just consider them as references. What's the juicy part here is this IRTS folder, which stands for irregular time series. And other than the dates, what contains is a stream of tick events exported or imported from those packet capture files. And there is some statistics also, which will become apparent why they are so useful. And the trading days index that just tell us like what sort of days we have in the database. The instruments itself seems to be mundane. Inside of the system, there is an entire area that we can discuss some other time of fast lookup tables and so on. But for now, we just set it aside and we go straight at the statistics and what we are interested in to pick out the most traded, like the most interesting stocks of the day, whatever was the last trading day. And some way we can load these statistics in, depending on your programming language. In this case, it's Julia, so it's rather flexible. And we examining the trade counts, but there are the statistics we could. If you go back here, then we can see them. Basically, event count, trade counts, and trade size, but other statistics could be extracted as well. We could sort them and pick out the top indices, which we could be interested in. And then somehow we could use the indexing facility to reverse map it back to names. So we would get something more informative to us, which is could be
just
useful.
for people who are not fluent in ticker symbols. I see Amazon, Nvidia, Apple near the top.
Yeah, these ones are probably that one of those things that we could recognize: AMD, Google, and some index and Tesla. Certainly on the
SPY is S&P.
Yeah.
Tesla. Okay.
So what I'm actually wondering, like, what's happening here? Okay. So this is the actual tick data, which is a stream of time entries, prices, size, contract ID. That's just basically usually some numbers, but there could be additional information and some flags, whether it was a trade, a bid, or some other events. There is information here, and I will fill in the documentation eventually, possibly in a week, so you get a better understanding what's happening. But what we're going to go through is just move on without any hesitation to pick some, how to say, like, to some way to reveal what's underneath. And here is a quick counting argument whether the numbers add up, but we can do a lot more than that. This is only just for verification purposes, so probably that's not interesting. If Gerd said something is like, hey, show me what you have, then I would say, okay, so what if we had this information that includes all sorts of tick data. And we want to pick out some interesting stocks. And then we would build a quick filtering and scan through that information. And what we would get on the screen is around 15,000 trade events for this stock. So that trade events is actual trades took place. That's reported to the SEC, or Security Exchange. Time information is in integers, so this is again a boring stuff, but each system requires some sort of like a native, or has some native representation, and somehow you have to, how to say, like map it back from integers. So it is this technical thing, is not so interesting. The prices are, so if you, well, some way would be prices here, control, yeah. So those errors is like I'm massaging a different letter on the keyboard, and that's sometimes like, that can happen. But if we plotted these ones, now this is what it is. So probably this is where we should start normally and then just go back. So this is actual plots for the specific index that we picked. And we could do that one by querying the instruments, and we know we had I that we picked out, so it would be this stock, whatever it is. I have no idea. Possibly. So that's in a nutshell. So what we saw here is the irregularly spaced trade events visualized, parsed and visualized in some information system or statistical system, specifically Julia, but that's not so interesting. The interesting part is that that's what we ignore, that these things happened like this. That's the interesting part. If you tried it like you tried to approach the same thing, and that's the alternative that I currently can't really show. So we take this one for granted, but this is actually the work of the HDF group and many other people. That is this information can be so snappy and just appear on your screen, plotted, and all those. That's the work of many others. But here we are. So we could visualize this information right here, and we can do that actually at a massive scale. So this actually scales to many computers, and that's not new to HDF5 users. In fact, probably one of the properties that they're using HDF5 systems. Now, what other things can be done, and this is where actually interesting. So this is appears to be snappy, but not snappy enough. So when we do actual computations, say conic programming to pick out stocks, given some criteria, which is known as portfolio optimization, then we examining many of them. Thousands, tens of thousands, depend on the space that we have. And when we do that one, then the computation gets harder and harder. And there is some numbers to it, like some people throw around like cubic or 2.7 something as a complexity. Because of it, and for many others, it seems to be more reasonable to have this information that currently we have in irregularly spaced, to organize it and just sample it from a regular time interval. Because if we did that one, then we could work with mathematical constructs like rank 1, rank n systems. What is more interesting and applicable in our case is rank 2, which are matrices. So if we organize the data in some matrices, which I'm going to do in a second, probably we're just gonna go like this and pick out a few of them. And if we picked out the information now organized into matrices, then we could just roll with our mathematics. And one of the things that we could see in this information, some of the stocks or matrix columns have no entries. And this is fine, other than waste space. It is fine as long as we know what we are doing and we have a mechanism to drop out the ones we are not interested. And this is the sub-indexing. This is how sub-indexing works, but the mathematical approach would be getting the right permutation matrix to take this space into a different shape, what we are actually want to work with. Now, when we do these ones, we actually want to do it for many days. And in our case, like we have data of somewhere like 2,100 days of some sort. Let's just check out if we break IEX and tops. So I think we have, but something doesn't, yeah. So we have lots of information here. I think we have to do this word count part. And for some reasons, it doesn't want to do that. All right. So that's what it is. But we have run few dozen days of information. So sampling the original IRTS data into something smaller chunks makes more sense. We can work with it mathematically, and this is what actually the system does. So what this utility allows you to do, take information that is recorded into Ethernet frames and compressed, decompresses it on the fly, then records that information into HDF5 streams called packet tables, which are regular chunk data, and have it available for you as an IR irregularly spaced samples in structs. In the same step, should you require, but suggested in different steps, you sample from these IRTS space into regular intervals, the way you desire, every second, every 10 seconds, every minute. And then you, when you map this stream of information into mathematical constructs, rank 2 or matrices. Loading these matrices are super fast, and working with them both from paper pencil theoretical approach and in statistical systems is easy. So just to recap, the IEX2H5 project's purpose, or what it does, is to take Ethernet trade streams, processes it or records it into HDF5 format, dropping out all the information that is not needed, and allowing you to have different compressors. And once you have this information, you can resample or further transform this information into blocks that you can work with both theoretically and practically in your computational system.
Fantastic. Yeah. Thank you. So what I'm going to do is I'm going to open up the floor. Any questions for Stephen or any questions about HDF5 in general? And then I have a book recommendation. So if this topic interests you, I've been listening to an audiobook for a while, and it's about the world of finance, written by someone who's done it sort of right then and there. It's the book. It's real. It's not fiction. In the UK, he worked for Citibank in London, and it's a fascinating account what happened sort of between, I believe, about 2007 into 2018. But I'll wait with that. Any questions?
Yes, I have one.
Go ahead.
Is there anyone not from HDF Group? I'll yield to the person not in HDF Group to ask first. as a good host or co-host.
No, go ahead.
No, all right. So here goes. So since you are releasing this tool publicly, have you ever thought about that you actually somehow make the structure of HDF5 files some kind of a convention, so that it is not only done by that tool or your tool, and that basically it can maybe help others to write their own tools with the same HDF5 file content and structure, so that it becomes, you know, more widely used. Because I'm assuming, you know, even high frequency time series data, it's a very common type of data in many other science and engineering fields. And so that would be my question first.
My question first, is it Alexander Jelenak?
Yes, that's me.
Nice to meet you. I met you on
Likewise.
the forums.
Yes,
First of
that's
all,
me.
many times. And yes, I brought this up some time ago, possibly in written form on the forums or only with words. And there are some technical details to it, but the answer is yes. This can be standardized. This can be done many ways. Which includes using attributes and mechanisms like that. But probably just leave it at this level, if I answered your question.
Yes, thank you. We now have certain capabilities that we can support development and recording of those conventions that we did not have until recently. So that may be something that Gerd and you and maybe me can discuss offline. The other only question I want to mention, so I like that you mentioned Zlib and G. It's something that I've been internally suggesting that it becomes a default build option for the HDF5 library. But I couldn't understand from your explanation, have you considered those lossy compression methods, the ones that basically say, especially the ones that say, I'm going to stop at certain decimal place of the floating point value, and all the other floating decimal places will be zero, just because that's not the accuracy I care about, or things like that. They're lossy, but in a way that basically they say my data is only good unto 3 decimal places, and anything after that 3 decimal places is just random noise. And therefore, I will force all of the data to be, all the other decimal places to be zeros afterwards. So have you considered those approaches for compression as well? Because they can compress really, really good.
So, I don't know how to answer this question in a way, but first of all, the problem not necessarily is there.
Okay.
This is unusual saying that or hearing it possibly, but how exchanges work is that you match up. Just let's back down. So how order books work is that you have a distribution here in discrete queues.
Mm-hmm.
And then there is an order coming in, and then you take the top portion until the weight sums up what you have in this distribution. That's how it works. Inside of what you consider distribution, actually discrete levels, price levels, not continuous, there could be missing price levels. But what this structure suggests, that what you described doesn't exist when it comes to prices, at least in this format, because all numbers are discrete. In fact, when I build trading simulators, probably I should open source one, then what you see is that integers are used. What you saw there, that you saw floating values. So it has a point here, and this is why what you brought up here is interesting, because this is one side to it, but there is another side. And this is where it's applicable. So one side, one could argue that it's not really applicable because the prices are always discrete. And there is a point why it is, because you have order queues, and the queues has to be like in a discrete like settings. But what we're recording into the RTS component, which is the rank 2 or matrices, are a result of a mathematical transformation. So you have some black box, a function that does something. It could be a linear time invariant system, which is a good model for it, with some details, say Kalman filtering or particle filtering, or you name it. And it does something to these numbers and results to somewhere. And now those numbers are in some format, which is floating point. In this case, some of that value has no actual meaning. The price cannot really be more than 4 decimal points on IEX.
All right.
Right.
Thank you. Thank you very much. I'm out of questions.
Good.
I gave enough time for others to come up with their shows.
Great question.
Thank you.
Other question, Mike? You had a question. Go ahead, please.
Yeah, I wondered. So, have you had some other folks download it and start using it in other institutions, either financial or academic or whatever? Had any
Great
experience
question, Mike. I think I finished it somewhere like midnight yesterday, to the point that it actually works. So I still have doubts, but I have hopes too.
Okay,
I
good.
believe if this absolutely applies to Gerd, who is also a member of an institution, he confirmed it this morning, it worked.
Okay, good.
This goes to underline the exclusivity of the content that we present during these events. It's hot off the press. It couldn't be more fresh.
Okay,
So,
okay, got you.
This is fresh out of the oven. But
yeah.
also, Mike, this is a very niche area. So the expectation here is not inventing like Twitter, or this is not a popular subject everywhere. This is not an image, how to say, like probably a song or an image that would go viral. That's not the point. This is to allow others to examine what's there, or if should they want to take it further to improve.
Okay.
This is not a trading system. I do have trading systems proprietary, which are not on the. This is not a proprietary data system either. It's actually taken out of a proprietary data system.
Well, I was thinking, here at the university in the business college, there are students doing research on financial data. And I know in the past, there have been some who've used HDF5, and they've gotten sample data from Nanex up in Chicago. And I don't know that that's different from what you have here. So anyway, that might be a potential place to find some users.
So what the difference could be is that you can have proprietary data. I do have proprietary data. I'm not licensed to discuss, or even if I discuss this one publicly, you won't be able to verify my results. I can say whatever I wanted. Mike, you won't be able to verify that because you won't have access to that data unless you say many things, and now you're in the same little corner that you won't be able to tell to others, which is not very helpful. So what this one does is opens the door to a room where you can walk in and you can take that information out and show it to others. That's what it does.
Oh, okay. Okay.
So those students or professionals can use this data, one format or another, and publish their results, and which can be verified.
Okay.
Say, yes, you did it, and say somebody like calls out on them. I kept trying doing that, what you described, and I'm not getting the result. Can you please explain? Either way, that's what it does.
Yeah.
Mm-hmm. Other questions, comments? No? Then great. Let me quickly share my screen here. I pasted the link for my book recommendation in the chat. But yeah, this book is by Gary Stevenson. It's called The Trading Game, A Confession. Fascinating book. Get it at your favorite bookseller, and it's also available as an audiobook and on your e-reader and so forth. But yeah, if you want to know more about what's happening on these trading floors and so forth, and also the whole social fabric around it, it's just a fascinating description, and I encourage you read it. And yeah, so that brings us to the end of today's clinic, I think, which was very exciting, and I'll keep an eye on the stars on Steve's GitHub repository on the view count for this video, and I'm sure it's gonna explode at some point. And yeah, thank you, Stephen, again for taking the time to speak with us and yeah, give us the honor to be the first ones to highlight your project. And yeah, we look forward to many more good and interesting things that you are doing with HDF5 that we can do together. And yeah, please come back soon.
Why, thank you very much for the opportunity. This is out of the current standing. This is a working project. And other than HDF5, people can check out for themselves how other alternative solutions behave in terms of performance. Something like 60 million ticks per second on a computer, respect to 1 million in a good case, gives a significant difference. And when it comes to pockets, how much you're spending on Amazon, 60 to 120 fold of a difference could have an impact on your yearly spending.
Yeah, yeah. Okay, great. Thanks everybody for coming. Come back next time and enjoy the rest of your day.
Thank you very much.
You.
Same
Thank
to
you, Gerd.
Yeah, bye.